This question asks us to find the coordinates of a local max in the function, and also any coordinates of a local minimum in the function. I'm going to imagine that the function is the surface of the ground that I'm walking on. And let's let up toward the top be the sky, so I'll put a little sun up there. And let's put a figure walking around on this terrain. Okay, so when we look for a local max, we're looking for points that are mountains, that are peaks. And this point right here would definitely fit that criteria. So that is what is called a local max. Now, how do we know that it is technically a local max? Well, our function has to be increasing to the left of the point. Function increases on the left of the peak, and then the function has to decrease on the right of the peak. So the point 0, 2 fits that criteria, and that is a local max. Now let's look for a local min. These would be the valleys, and there are two of them in this picture. Now, how do you know for sure that you've identified a local min? Well, your function is decreasing to the left of the valley, and your function has to increase to the right. So the curve has to go down and then back up. If it doesn't go back up, then it's not really a valley. So what are the coordinates here? -2, -2, and 2, -2. There are two local mins. Okay. In the lower right, there's another function. And let's try to identify the min and max. If it helps, draw your person walking on the curve. And for a max, we're looking for where does our guy have to walk up to get to this point, and then has to walk down to the right of that. That would be this point right here. That is actually a local max. Notice it doesn't have to be the highest point that the function reaches. Like for example, points over here are much higher in elevation, but it's a local max because it's the highest point in his local area. The coordinates are -2, -1. And this point here is going to be a local min. It is the lowest point in its local area So its coordinates are 2, comma 1.